Hey friends, welcome to Algebra Lesson 6, Simplifying Expressions. The first thing I'd like you to do is pause the video and go ahead and solve all of the substitution problems that are on your first page of notes. Then come back and check your work. All right, we have x equals 4 squared divided by 8 minus 2 squared in parentheses plus 50. First thing we need to do, of course, is solve in the parentheses. So we will expand that 2 to start with, since that's an exponent. And then we'll work within the parentheses. So now we have 8 minus 2 times 2, of course, is 4. And then finish writing the rest of our problem. And now let's finish solving in the parentheses. So 8 minus 4 is 4. And then we'll finish writing our problem. Now we need to solve these exponents here. We've got 4 squared, so we need to expand that to 4 times 4. Finish writing the problem. And then 4 times 4, of course, is 16. 16 divided by 4 is 4. And that means that x equals 54. Okay, so now we're going to solve some substitution problems. Hopefully you've already done that. And the first one you have on your paper is m to the third power minus 20. So we will rewrite the problem and then we will substitute in 4. So we have 4 times 4 times 4 minus 20. 4 times 4 is 16 times 4 minus 20. 16 times 4 is 64 minus 20, and your answer is 44. All right, next you have 3 times n divided by 2. So let's start by rewriting the problem and then substituting in 4 for m. Now we have 3 times 4 divided by 2. We multiply 3 times 4, we get 12 divided by 2, and the answer is 6. All right, 50 minus 3m squared. Let's rewrite the problem. And let's substitute in 4 for the m. So now we have 50 minus 3 times 4 squared. Now let's expand the 4. And now let's start multiplying. 50 minus 3 times 16. And then we have 3 times 16 is 48, so 50 minus 48. And our answer is 2. All right, now we're starting the real notes. So you have notes at the top of your page, and I'd like you to fill in the blanks. Terms containing the same letter, variable or unknown, are called like terms. Terms that are just numbers without a variable are also like terms to each other. When we simplify expressions, we can combine like terms, but we cannot combine terms that are not alike. So let's take a look at what this means. Joseph has, I have John, you have Joseph on your notes. I have John on my PowerPoint. Sorry about that. But you have Joseph has 4 bags of red beads and 3 bags of green beads. There are X beads in each bag. So we've got red beads over here, and we've got X number of green bags, X in those green bags over here. So we want to find the total number of beads in terms of X. So the number of red beads is going to be, of course, 4 times X. The number of green beads, we've got 3 bags of X beads, so that's going to be 3x. Now, if we want the total number of beads, we can just do, well, let's draw a model here. We've got, let's pretend this model represents our beads. So we've got 1, 2, 3, 4 bags of X beads. And then we've got 1, 2, 3 bags, and I'm going to shade those because they're the different bags of X beads. And of course, all together, we have 4x plus 3x. We have 7x bags of beads. So we would write that like this. So 4x plus 3x equals 7x beads. All right, now we want to know how many more red beads than green beads are there. So let's draw ourselves another model over here. So if we have, so each one of these little boxes represents one bag of beads. So up here we have 4x beads. And that's our red beads. And now down here, each one of these little squares equals a bag of x beads. And that's 3x beads. And we can see by looking at this model that if we were to subtract 3x beads from 4x beads, or find the difference, we would end up with 1x beads, which we just write as x, okay? So we would write that 4x minus 3x, which would equal 1x, but we don't write that, remember, because of algebraic notation. So we would just write x beads. Now I just want to show you one other way that we could model this. That would be a little bit easier than our first way. We could also model it like this, where we start with 4x beads, right? And then we take away 3x beads. Oops, my pointer's going a little bit wonky on me. Oh well. So we take away 3x beads. We're going to be left with 1x. Okay. If we start with 7 bags of red beads and take away 3 bags, how many beads are left? So let's start with 7. We're just going to model like this time. We start with 7 bags of red beads, and remember the number of beads inside the bags are x. We don't actually know how many are in there, so we're just calling them x. So we start with 7. 1, 2, 3, 4, 5, 6, 7. And we take away 3 bags. So 3x bags. How many are left? So you can see from looking at the model that there are going to be 4x bags left, right? But let's write this as an algebraic equation. So 7x minus 3x is going to be 4x bags of beads, right? Or 4x beads, I should say. So you can see that I can take away 3x from 7x because it's the same, I'm talking about the same kind of unit. In all of these bags there are x number of beads, and since I'm talking about the same thing, I can add and subtract x's all day long. Those are like terms. Now let's take a look at what the difference between like terms and unlike terms is. Okay, if we start with 6 bags of n marbles, then we give away 3 bags of n marbles and buy 2 bags of n marbles. How many marbles do we have? There are multiple things happening in this problem. First, I start with 6, then I give away 3 bags of marbles, and then I buy 2 more bags of marbles. So let's see what that looks like. So I've got 6 bags of n marbles. 1, 2, 3, 4, 5, 6. Okay, that's what I start with, right? Now I'm going to give away 3 bags of n marbles. So let's give away those marbles. Okay, now I'm going to buy 2 bags of n marbles. So let's not move on to that part of the problem yet. Let's draw a line under here just to kind of help us keep our steps straight here. So first I started with 6n, right? Then it said we gave away 3 bags of n marbles. Okay, so I've got 6n. Now I'm going to give some away. I'm going to give away 3n bags of marbles. So that's where I'm at this point. Now the second part of my problem says, and buy 2 bags of N marbles. So I'm going to add back in 2 bags of N marbles. How many marbles do I now have? Well, in the first part of my problem, I had 6N minus 3N, and now I'm adding back in 2N marbles. So let's take this over here. 6N minus 3N. Let me rewrite that. 6N minus 3N plus 2N. Let's see if we can figure out how many marbles we have. 6N minus 3N is 3N. And then if I add everything up, I have 5N marbles. So you can see that from the model. I've got 1, 2, 3, 4, 5. Okay, not hard. Now, let's find the total number of marbles if N equals 10. So remember, I had 6N minus 3N plus 2N. So now I'm going to do some substitution. I have 6 times 10 minus 3 times 10 plus 2 times 10. So let's work that out. 6 times 10 is 60. 3 times 10 is 30. 2 times 10 is 20. So I should have 60 minus 30 is 30 plus 20, 50 marbles. Okay, so let's do this without substituting in 10 for all of those things and wait until the end to substitute in 10. Here's what I mean. We started out with 6N minus 3N plus 2N, right? If we just work with the n's until the end and then substitute, let's see if we get the same thing. So 6N minus 3N is 3N. And then 3N plus 2N is 5N. Now if we substitute in 10 for N, do we get the same thing? Yeah. Okay. Okay, are these expressions the same? On the left we have 6N minus 3N plus 2N, and on the right we have 6N plus 2N minus 3N. Well, let's solve them and find out. 6N minus 3N is 3N, plus 2N is 5N. 6N plus 2N is 8N, minus 3N is 5N. So yes, these two expressions are the same. We can add and subtract in any order as long as we keep the terms' signs. And the signs that belong with the terms are to the left of the terms. And we're going to practice this a whole lot in about a minute. Okay, another example. If we have 2 bags containing N marbles and 3 additional single marbles, write an expression for the total number of marbles. So now we've got 2 bags containing N marbles, and we have 3 little extra random marbles on the side. So here we have 2N, and here we have 3. So we would write that expression 2N plus 3 marbles. Now, can I go ahead and add those terms up? I have 2N as a term in that expression, and I have 3 as a term in that expression. The answer is no, I cannot add those up because, as you can see, N might stand for 100 marbles, it might stand for 1,000 marbles, it might stand for 10 marbles. We don't know how many marbles are in these 2 bags right here. But we do know that these are just single marbles. So those are not like terms. We cannot add those up. Okay, I would like you to continue watching part 2 of this video. It will be called Simplifying Expressions Part 2.